Hello everyone, thanks for joining me in this session where I will introduce our company and products to you. So my name is Mathis Menou, I'm the sales manager of Femto and I will be glad to show this presentation to you. So I will start by sharing this screen right here. And the topic today will be to introduce some innovation in the field of ultrafast laser characterization and how you could easily characterize those pulses with our devices. So a few words about Femto. So we are a small and young company, just celebrated our 5th anniversary. And we are located in Bordeaux in France, and we are a spin-off from the Celia laboratory from the University of Bordeaux. Our company was founded by a laser physicist, Antoine Dubrouille, and a expert software developer, Stéphane Lecornet, 5 years ago. So currently, our company is made of about 10 people. And we have been operating a few patents coming from the CNRS, which is the National Organization for Research in France, and also some patents that we have on our own. So our key domains of expertise are related to ultrafast lasers. And for those lasers, we provide the temporal measurements, spectral measurements, spatial measurement, but also frequency conversion. So all of these devices actually are for ultrafast lasers, but we also have some of these diagnostics that are for regular lasers, not necessarily ultrafast. So as most of these diagnostics are based on software, we also have a strong expertise in-house for software development, and it's in our philosophy to offer the best software experience to our customers. So in this respect, all our products that relies on software have the most advanced and most easy to use software available on the market. So our range of product starts from temporal measurement. So as you may know, it's not very easy to measure the pulse duration of ultrafast lasers, namely picosecond or femtosecond laser. And as conventional method cannot be used for measuring those lasers, you have to use specific devices such as Autocorrelator. So our main product is actually the ROC, which stands for Raw Optical Correlator. And it is an innovative design of single-shot autocorrelation. So unlike the conventional technique that are based on a translation stage that is moved to scan the pulse, the duration of the pulse. In our design, only one pulse can be used to measure the whole information. So in this respect, there are no moving parts. So the system is robust and compact. I can show you an example here. So this is typically our ROC. So it's a very compact and robust design that can be used easily when there is not much room on the optical table, or when some robustness are also required. So these devices are actually, thanks to our design, very easy to align. So that's one of the key points of this autocorrelator. So unlike conventional technique where you have to spend a long time for alignment, here you can do it in a few seconds, and I show you on the next slide. So next point is that even though those autocorrelators are a single shot, based on single shot technique, they can also work with high rep rate lasers like megahertz or gigahertz laser. It's not a problem. Only at these rep rates, the single pulse information cannot be measured, but you will measure an accumulation of pulses. But that's actually not a problem. So as I mentioned before, this ROC autocorrelator is also having a very nice software, very powerful. So it can measure pulses ranging from 5 femtosecond up to 10 picosecond with different models. And in terms of wavelengths, it starts from 480 nanometer up to 2.1 micron. So this is typically how you can align this autocorrelator. So first, you just have to make sure that the device is at the right height of the beam. So you just put it up or down at the rough height of the beam. Then you just open the laser beam, put the rock, center the rock on the beam. And then when it's done, you just have to rotate the back and until you get the signal, which is very easy and very tolerant to misalignment. So it really takes a few seconds to get the measurement done. So that's quite an achievement for such kind of instrumentation. Recently, we have actually pushed that concept of single-shot autocorrelation to its very limit by introducing definitely the most compact femtosecond autocorrelator ever. The name is MicroRock, and it's really very small. It's as small as a regular camera. So here I have one that I can show you. So this is actually the MicroRock. So unlike conventional technique, which are usually quite bulky and takes a lot of space, this device can really be integrated in a laser head or in a laser system using ultrafast laser. So currently we have developed two models for two different types of lasers. One is the titanium sapphire lasers around 800 nanometer, and the other type of laser is ytterbium laser around 1 micron. So we have these two models, and they are compact, easy to align, and easy to integrate, as we are based, our software is based on a REST API, which is a standard communication protocol based on a HTTP request. So that's a pretty new and revolutionary product, and we are happy to introduce it to the market today. So next, our second range of product beside autocorrelators is the frog. So frog takes the temporal measurement a step forward. So instead of just measuring the pulse duration information, we also have the spectral phase and the whole temporal profile that can be measured. So the frog is a little bit more complex, and but still, thanks to the design brought by Femto Easy, it's still quite easy to use. So the frog works on the same kind of range for a few femtosecond to a few tens of picosecond, and from 500 nanometer to 2 micron, can be extended a little bit on both edges. As for the autocorrelator, the software is also a key part of the product, and the alignment is also something quite easy compared to, again, conventional techniques. Actually, inside this frog device, one very key component, I can say, is the spectrometer. So for the single shot frog technique, we have to be based on the imaging spectrometer, a 2D spectrometer. So as we needed it for our frog, single shot frog, we have decided to make a product out of it that can be used as a standalone imaging spectrometer. So that's the MIS, mini imaging spatial spectrometer, that you see here on the slide. And this is actually one sub-component, I can say, of the frog. So it has been designed to be plug and play, meaning that it can be easily swapped inside the frog to change the wavelength range. So it takes a few seconds, no realignment needed, and then you can completely change the range of your frog. And again, can be used as a standard product to measure the spatial chop, for example, of the laser. Besides all those products that are more for ultrafast lasers, we also have developed a range of laser beam profilers that can be used for other types of laser, nanosecond, CW. So these laser beam profilers actually measure the beam profile, beam diameter, a lot of characterization, beam pointing about the laser. So again, thanks to our advanced software, these devices can work with very advanced cameras, so with large resolution, with small pixels, and that could be manipulated by this software while keeping good refreshment rate and frame per second rate. So we have a range of different beam profilers, small, very compact, large diameter, large resolution. So feel free to contact us for more details about those beam profilers. Another range of expertise that we have at Femto is the frequency conversion. So we are able actually to convert ultra-fast pulses even with low energy and using compact, rugged, and industrial design for this kind of conversion unit. So as you can see here, we are able to couple this conversion module to any kind of standard laser from the industry, and then it offers the customer access to wavelengths that are usually hard to get, like 266 nanometer, for example, even with the low energy in the IR. Usually there are low energy, high rep rate lasers that we can convert to third or fourth harmonic. So that was the quick introduction about our company. So I encourage you to contact me if you want more details about what we are doing. You can visit our website, you can send an email, or even go to the website for having a live chat session. So thanks for your attention, and I hope to talk to you soon. Bye-bye.